So today we're going to talk about urban acoustics. How do we make sure folks like the housing they live in? So we're talking about multifamily housing. Here's some of the housekeeping things, but really we're going to help establish expectations. And that's where the biggest problem is in urban acoustics, is what is the expectation of the folks that are going to be living in the housing? And we're going to talk about some building codes and some changes that are occurring. And yeah, so let's step back and think where we came from. Okay. Our ancestors came from Europe, higher density housing. They moved to the shores, the larger cities, multi-story walk-ups, high density. Okay. So we're used to having that, and we go back to where we came from. The loudest thing we had, if you were lucky, was maybe a player piano or something in the unit next door. Or maybe it was that domestic spat that was going on. Those were the things that we had historically. So now we're dealing with all kinds of other things. We've got entertainment, we have retail, we have activities outside our multifamily housing, our mixed-use facilities. Trash, how was it gotten rid of before? It was just having to be dumped out the window, right? So now we've got trash pickup, we've got buses, we've got transportation. We have a lot of different things that create problems for us from a noise point of view. And this is the expectation that we always seem to have. This is what I see when we get called in to fix something. They're expecting that, so versus something that's in mixed use, versus just general multifamily housing. So let's roll up our sleeves here. All right, the first premise we have is building code. Our goal as acousticians, as designers, is to keep noise out. How do we keep noise out from adjacent units, units above and below? So can anyone tell me what the building code is for entry-level housing? Does anyone have a STC 50, thank you. All right, so entry level is giving us a STC rating or an ASTC rating of 50. That's what the code says we have to have between units. What do we have to have between market rate? Does the code talk about that? 50, very good, there's no difference. What about for luxury? 50, okay. So the building code only speaks to minimum quality construction from an acoustical point of view, and that's our challenge. How many people here are architects, designers? How many people are developers? Engineers? Okay. Manufacturers, building component people? Okay, a few, all right. So we got a good group. So these are our challenges, is establishing expectation. And our biggest expectation issue is when marketing gets involved. We may be sitting at those design team meetings and the expectation is, oh, this is going to be market rate, and all of a sudden the flyer comes up and it says it's luxury grade. Those are our challenges. This came about in the States back in the 60s, where HUD, and now the Federal Housing Association, now HUD, established the minimum criteria for entry-level housing. After that, they had suggestions for market rate as well as luxury. And we're still using those extra steps today. So if you talk to an acoustical consultant and you tell them that you're working on a project that wants to be luxury grade, we're going to be steering you in the direction of a STC IIC 60-ish system. And we'll talk more about that terminology in a bit. Okay. The International Code Council for the International Building Code in the United States is now adopting a network or a workbook to supplement the acoustical section. And they're just now starting to talk about these other versions. Now, these are not codes in the States, but they are suggestions. So as you're working on projects and you're determining what type of project it's going to be as far as market, luxury, entry level, be thinking about these changes and these increases in the acoustical isolation. Canadian National Building Code, again, establishes a STC of 50 from a design point of view, or an apparent sound transmission class, an ASTC, which is a new term for a lot of you, of 47. So historically, when you've looked at the code, it's been FSTC, a field-tested sound transmission class, or a field-tested impact isolation class. So that's being brought up now, okay? As we go further, they're looking for elevators to, or sleeping units within the same area to be separated by 43, so say in a hotel type facility like we have here. Elevator shafts and trash chutes, those types of things. They're looking for a rating of 55 separation, which is great. We don't have anything like that in the States, it's just 50. A part that the Canadian Building Code is silent on is impact isolation. So that's the footfall noise, that's the thump thump. That's the person walking around in the hotel room last night above me all night long, thump 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 thump. So that's a challenge. Okay. Something else that we're looking for is exterior to interior. Now that is not an issue as much here in Canada as it is down in the south where our Raleigh, Durham, and our Orlando offices are. Because typically the windows in my house in San Francisco isn't insulated. Now I grew up about 50 kilometers south of here, okay, in Michigan, and went to school about 300 kilometers north of here, again in Michigan, in the middle of Lake Superior. I know what cold is, just as you do. So having the thermal wrap of our dwelling units takes care of most of the exterior to interior acoustical issues that we have. So again, having gaskets on doors, windows that's sealed, building insulation, that takes care of it. So that and fire ratings are my two favorite friends. If I have a fire rating of an assembly, that's generally going to help us acoustically. Challenges we have when we get into mixed use is what is that separation? Now this is a project that we did. This is 2 miles south of our Raleigh-Durham office. And we talked to them about having isolation between the commercial units on the lower level and the housing above, 3 stories of housing above. Wood frame, wouldn't listen to us, oh no, it's not a problem. Well, we got a call in, and how do we fix Buffalo Wild Wings when they have open mic night? Not only is it loud, it's also bad, from the units above. 2 of my engineers were in this complex and they all broke their lease and moved out because it was too noisy. So when we start looking at this, we're dealing with commercial to residential complaints. This is typically a nuisance complaint that the police will come out and deal with. If they happen to get out there at the right time to measure it, great. Obviously they don't have a lot of time to deal with nuisance complaints from noise, but that's how commercial to residential is generally dealt with. Even though we've got that STC 50 requirement, if it's exceeding that or making excessive noise, it's going to be a complaint to the police department. Okay, some really great things going on here. Next week in Ontario is 2 days of classes. It's Acoustics Week in Canada. So the Research Council, they're going to be doing some presentations there. If you've got a chance to go over there, they're going to go into more detail about how to calculate ASTC. Robert Marshall from Certainteed is going to be in here. There you are. And talking about ASTC in more detail later on today. So I'm not going to go in a lot of detail on how to calculate that. So we've been throwing around some terms. Let's help define this. I'm in an industry of jargon, second only to IT. So when we start talking about things, general terms that you hear about in acoustics, is going to be noise reduction. How much sound is measured from one side of the wall to the next? How much is it reduced? It could be exterior, it could be interior, but it's noise reduction. A-weighted sound pressure levels, that's kind of what our ear hears, and that's what you're going to have on your sound level meters. You're going to more cheaper sound level meters, single-digit sound meters. That's going to be used for environmental noise. How loud is the environment? And those metrics are used with day-night average sound levels, community noise equivalent levels, and then we start looking at windows to provide that isolation. That's going to be outside to inside transmission loss, OITC. When we start looking at partitions, and we're dealing with sound, we start with sound transmission class, STC rating. That's a single number that's measured in a laboratory, and we'll show you some pictures of the labs coming up of how much sound that partition is going to block. It's a lot like, if you want to think about it, like a fire rating, but we're dealing with sound. FSTC is a field measured sound transmission class. That standard has been replaced by ASTC. Now, you folks in Canada are about a code revision ahead of us in adopting the new ASTM standards. So in the United States, I'm not dealing with ASTC yet. When we come up with our next building code, we should have everything in and rolled into that. Noise isolation class is a simple measurement of how much noise is on this side of the wall and how much do I have on the other side of the wall. Simple thing like that. So ASTC, again, is taking into account all of the paths, flanking paths and things like that. So that's sound. That's what you're hearing from here out into the hallway. Then we get into impact. How much noise do we have from a footfall point of view? What are the surfaces above? How do we control that? So that's impact isolation class. If we measure it in the field, the old terminology was field, FIIC, field impact class. Now it's apparent impact class. If you haven't seen the curves that I'm talking about, the curve on the right of the screen, that is an STC contour, that straight line, or the segments that are relatively straight, the three-segmented curve. That is the sound transmission curve. That's established by ASTM. On the left-hand side is the impact isolation curve. That three-segmented curve is also established by ASTM. We measure and figure out what the difference is in the sound from one side of the wall to the next, and then do a curve fit. So here's that acoustical lab where we would be doing the STC testing. It's a very, very thick and massive wall. The only weak link is going to be that 10-meter opening in the middle of the wall, 100 square feet. It's 100 square feet, so a little less than 10 meters, 10 square meters. The partition under test is built into that opening, sealed airtight. Then we create a tremendous amount of noise on one side of the wall, and then measure it typically into an anechoic, which is on the right-hand side of your image. That difference gives us and allows us to calculate the STC rating. Okay. Again, STC is just the partition in the laboratory. ASTC is going to take into account all of the different paths. The flanking paths through the floor, as sound travels over the ceiling, all the different paths. IIC, we're not using a loudspeaker, we're using a tapping machine. And we'll see more about that in a bit. So that tapping machine gives us the ability to create a noise, known sound level overhead, and then we can measure all of this, the sound level in the room below through all the adjacent paths. Directly through the floor, directly coming through the walls that is being re-radiated. So after we've done our measurement, and let's say our gold here is our code gold of STC 50. So that's the STC 50 line in blue. We measure the sound levels below that in that room, and we get what's measured on the red line there. Now our goal is, and the way we calculate an STC or an IIC rating is, it's a twofold true-false test. I can only have 32 deviations below the curve, deviation points, and I can have no more deviations in any one band more than 8. So as you look at this, you can see I've got at the bottom there, it's 60 deviation points if you add up all the numbers below. And at that one frequency, we've got 50 deviation, or 10 deviation points. So this partition that we measured does not meet STC 50. It's substandard. if STC 50 is what it was supposed to do. So we move that curve down 1 point all the way across. That becomes an STC 49 curve then. And these are referenced off from one of the center frequency at 500 hertz. So if we look at, let's see, do we have a mouse here? So we look at that knee point right there. That's our reference point. We still have over 40 deviation points. So we move the curve down again. We're still over 40, but we're just now at 88 points for that one band. We move the curve down again. We meet the 8 points, and we've got our 31 points of deviation. So the partition that we tested was not an STC 50 partition, but rather an STC 47 partition. So if this was in the field, this would be ASTC 47. That's the process we go through. A lot of people have asked about it. It's not that complicated, but that's the steps that we go through in determining what the STC or IIC rating is. The biggest point we're going to have you take away now that we talked about the terms is there is no silver bullet. I cannot provide a building made out of concrete, a building made out of steel or metal, a building made out of wood that meets STC ratings that we're looking for. It has to be a combination of materials and systems. Okay? Regardless of how we're putting it together, there's not one building method out there that achieves the acoustical ratings all on their own. Okay? So let's look at the wall systems. Okay? Acoustically, we assume that our walls are full height. Okay? Structure to structure. We assume that our walls and our acoustic materials are insulated with some type of thermal insulation, open cell thermal insulation. We assume that they're sealed airtight around the perimeter, gasketed. For flooring, acoustically, I want them to be glued and screwed. Okay? I don't want those nails to pop out. I do not want the nail squeak as people are walking around. So we start looking at our progression of the wood walls. The standard stud wall, uninsulated, when we measure it in the field, is STC 34. As soon as we add bad insulation into that system, layer of gypsum board, insulation, layer of gypsum board, we jump up to STC 38. So we get about 6 STC points. On average, we say insulation's worth about 5 STC points. We kind of wave our hands, we're looking at systems. So when I went to Lowe's this weekend, or Wednesday, to check on price, for 30 cents a square foot, I can add that insulation. That is the cheapest way we can improve the acoustical isolation in any of our systems, is to make sure that the stud or joist cavity has insulation in it. Okay? Typically, we're looking to either fill the cavity or have at least 6 inches of it in the cavity. We're looking at joist cavities. When we go to the next progression of 2 layers of gypsum board on each side, so we got a total of 4 layers, insulation, we're only up at STC 45. So that really doesn't deal with our demising walls between units and may deal with demising walls in the hotel. To get to STC 50, we have to add some type of resilient system. And historically, that's been a resilient channel. So here we've got a single layer of gypsum board on one side, an insulated stud system, a resilient system to resilient channel, and then 2 layers of gypsum board on the outside. That gets us to STC 50. My favorite wall, my go-to construction when we're dealing with wood frame multifamily housing, is that double stud wall. That gets us up into the mid STC 60s between where we're testing it. 4 layers of gypsum board, 2 and 2, 2 sets of studs, 2 sets of insulation, and we ask for 1.5 inch airspace. There are some isolators out there that if the building inspector comes back and says it has to be blocked, it still gives us the blocking, but it gives us the structural disconnect that we need. Anything more than STC 65, we are dealing with studio construction. The flanking paths, the sound traveling through the floor, up and around all the different connection portions, the exterior walls, are going to be limiting the STC rating to about 65. Okay. So if I want more than that, I've got to go to studio construction, floating floors, sprung ceilings, things like that. When we look at staggered stud, which we can do in wood framing, a single staggered stud with a layer of gypsum board still doesn't get us there. It's only STC 59, so we're going to need multiple layers of gypsum board. We talked about that resilient system. Most commonly, it's considered a resilient channel. Okay? Metal channels are not all the same. The top one's a hat channel. Everyone should be familiar with that, I hope. Basically looks like a hat. The bottom one is a resilient channel. The resilient channel does not have that top leg, so it's meant to float off from the structure. Now the challenge is the installation of the resilient channel, and all resilient channels are not created equal. So one of my colleagues out in Seattle did this review and test, or gathered the test data. The middle channel is what's been historically known as an RC1 channel. This is the channel that USG developed many, many years ago that's been used over and over again. And if we look at the ratio of open area to closed area, that slot, it's about 4 inches and it's about 1 inch. So 4 inches of open area roughly and about 1 inch of closed area roughly. So 80% of that leg is open, is resilient. The channel at the top was the next channel that they developed. They routed it out instead of punching it. Evidently it was faster and cheaper. That one still performed the same. The other three channels, channel 2, 4, and 5, are not the acoustical channels that we would recommend. Whenever we've gone in and done destructive testing for expert witness work, we've always found those channels in place. The partition didn't test well. When we went back in and established and tested using the USG, that larger ratio of open area to closed area, we've not had a problem. Okay. One of the other challenges we have with resilient channels, and we'll see some photos of it, is that channel is only 1/2 inch thick. And if the crew doing the work in the job site do not know where their framing members are, and they screw through the gypsum board, through the channel, into the framing system, we've just short-circuited the springs in our car. Okay? That resilient channel is no longer resilient, and you've just spent a whole lot of money and labor for nothing. And that's one of the major challenges. And that's why we've got different systems. Folks outside the door here are dealing with different types of isolation systems that minimize that possible connection. Okay? So we're looking at hockey puck type resilient systems, as I call them, where we attach a isolator to the framing system, whether it's wood or whether it's the wall or the ceiling. Then we have the ability to snap a hat channel in. Okay. The hat channel is about 3/4 of an inch, so it's standing off the framing system by about 1.5 inches by the time we get done here. We've got 5/8 inch gypsum board, maybe 2 layers of that. So as long as the drywall crew doesn't have deck screws in their bag, we should be fine. They're not going to be able to screw through the gypsum board through this resilient system into the framing. Okay. Does that make sense? Yeah? How are we doing? Is this going okay? Too fast, too slow? Just right? Okay. So as we start to look at how these are installed, so this is a really good system. Material-wise, it's more. Okay. But we don't need one of these hockey puck isolators at every framing intersection. So those can be typically 1 in 3, so every 3rd stud, every 3rd joist for that hat channel, because the hat channel is going to be stiffer, support the load, and it's going to be able to carry that weight. So I can have someone that's quasi-skilled understand how to put these in, mark them up very easily, and then we can go back and have our unskilled labor hang sheetrock. Lot lines, next great issue. A lot of times in acoustics, less is more, and this is one of those examples. So I've got my double stud wall, my favorite wall, and it's exaggerated here just so we can, the airspace is exaggerated just so we can go through this. We've got 2 layers of gypsum board, we've got the airspace, that's STC 63. If we're going with a lot line for fire issues, lot line wall with fire separation requirements, historically it's been built with something like detail number 2. Here I've got 6 layers of gypsum board total. And it performs substantially worse than my 4-layer system. That's due to 2 things. I've got a trapped airspace between my walls. How many people here can compress a basketball or a football? Anyone got the ability to do that here? Okay, it's a sphere, it's trapped air. We can't compress that. That's the same thing that happens. Those 2 walls are going to vibrate together because of that trapped airspace. Okay? Then I've got resonance in the building construction because I've got 2 identical systems. So when I have that 3-layer of gypsum board wall, it's got a certain inherent poor performance, lower performance, not poor performance, but lower performance at certain frequencies. When I couple 2 of them together, they let even more sound through at that area. You can see just by pulling out the 2 layers on the left, we go with 4 layers and having that one larger airspace, we get a substantial improvement. Okay, that's because of the resonance of the trapped airspace. And then finally, if we pull all of them out and just go with 2 layers, we're still doing better in meeting the code. Okay. So this is a question when less is more. Now we've got some really good test data now using shaft wall assemblies in that airspace that give us about STC 60, STC 65. So if we've got to do fire separation, let's frame up our walls in a balloon manner and then do that shaft wall in the center. Okay. Floor ceiling systems, just like our food chain for acoustics. We've got our standard 2-by, if we will, system, joist. We've got a layer of gypsum board screwed to the bottom, a layer of plywood on the top. We're at STC 37. I insulate it, we jump up to 43. Okay, again, that insulation for 50 cents, 30 cents a square foot, 6 inches, that was 40 cents a square foot. Very, very inexpensive for a substantial improvement. So if you ever wonder why the kids were so loud upstairs and you have a standard house that doesn't have insulated floors, that's the reason. As soon as we add a topping slab, gypcrete or lightweight concrete, we get almost to STC 50. We're at STC 49. USG, or gypcrete at the time, did test this report about 20 years ago, this system, and they got to STC 50 and there was a big stamp on it. Don't use it, we don't believe it. It was right on the edge. So we're like lightweight concrete to add additional mass. It helps seal the bottom of our partitions, adjacent partitions. Okay. That additional mass really helps us. It stiffens up the system. It provides better low frequency, better thump noise control. As soon as we put a resilient system, we're showing you here with a resilient channel, but a resilient system there, we get up to STC 56. And again, my go-to floor ceiling when we're dealing with this is going to be lightweight concrete of some sort, tongue and groove, subfloor so I don't have my squeaks at my joints, a resilient system, either resilient channels or some type of clip system, and then 2 layers of gypsum board. Again, we're at mid-60s there. We're not going to get any better until we start doing studio construction. It doesn't matter what that framing system is. Now we've got lots of data on 2-by material. Weyerhaeuser was great when they came out with their truss joists many, many years ago. They went through and did round-robin testing to prove that that product worked the same acoustically as stick-built framing. Okay. That's what we need from more manufacturers as we're identifying these. I don't have data from parallel cord trusses. I don't have data from open web trusses, but we know that at that thickness, those depths, it's going to perform essentially the same as acoustically as a stick-built or an I-beam joist or I-built system. The next step beyond that is really using some type of system, either the hockey puck system, or in this case, this is a framing system that you screw into the side of the joist and then it hangs down. And we can use that as our framing system. So not only is it offset a little bit from our joist, it is isolated from the joist. So we've got some options that way. Okay. How many people have been in a building where they've been jackhammering or saw cutting? And how far did you have to go in that building to get away from that noise? Out of the building, okay? That's the challenge we have when we got impact noise. We want to make sure that we're reducing that noise at the source. So we use a tapper machine. This is our tapping machine. Believe it or not, that's a $5,000 box 20 years ago. And the guts inside of it look like that. It's got 5 hammers that will run around a cam and they drop. So we have approximately a 10 hertz tone, 10 cycles a second. Okay. Every hammer drops twice, 5 of them. And that creates a repetitive noise. Rat-a-tat-tat, 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 rat-a-tat-tat. And that's what we measure downstairs. This is a ISO ASTM calibrated box that creates a no noise source. In the top right corner, you can see the hammers just starting to touch. We want to reduce that transfer of noise. So if we've got noise that's getting into the floor ceiling system and we're not isolating it, it's going to travel all the way through the system as we see on the left. If we can add some type of acoustical mat to our subfloor, okay, a lot of different options. And again, stop by folks outside there. We've got stuff for wood, we've got stuff for gypcrete. They're all going to work great, okay, from an acoustical point of view. I don't work for them. Okay. That's going to absorb the noise, reduce the transfer of noise in the space. And so if we look at the food chain, okay, of our STC 56 wall or floor ceiling system, we've got the bad insulations not being shown right now, but we've got it there. And we start looking at gypcrete, bare gypcrete, we're at impact isolation class 32. If we go to tile, we're at 43. Cushion back vinyl, we're at the mid 50s. Thin carpet, heavy carpet, we're 60 and 70. Okay. Because of the carpeting, that's the best thing. It's soft, it's absorptive, it deals with the footfall noise. So for all of you architects and interior designers out there, this is the reason you're going to start putting carpet in your kitchen and your bathrooms. Okay. We want to carpet the entire building. Okay. In lieu of that, then we have to start thinking about, do we put sound absorptive or impact material underneath the finished surface, be it wood or concrete or tile or whatever we've got? Do we put the material underneath our entire floating slab so you can do whatever you want in the future? So that floating subfloor, that gypcrete floor. It really, really does help. Okay, questions about that? Let's see how we're doing. Okay, we're there. CLTs, how many of you, yes sir? I would tend to disagree with that. The improvement we get, the biggest and cheapest improvement we get is adding insulation. Resilient channels does a lot more at lower frequencies. We also have the possibility of that getting easily screwed up. But step number one, I would insulate a cavity before I would put resilient channels on a cavity. Okay. Good question though. And everyone heard the question. The question was, what's the best bang for the buck? Resilient channels versus insulation. Okay. Yes, sir.
Back to your IIC slide, with the isolation membrane and not taking into account finishes, what do you expect?
Okay, looking at our IIC slide, a good timely comment. What do we expect if we have the isolation membrane without dealing with, assuming that we've got our subfloor, we've got the isolation membrane, we've got some type of lightweight concrete on top of that. We're going to start at about 52 IIC in the field. So it's pretty much a given that we will get to code compliant, maybe market rate housing with whatever surface we put on top without thinking anything more about it. CLTs, how many of you had a chance to use CLTs? How many of you looking at it? Okay. Download the CLT handbook. The stuff we're going to talk about is out of one of their chapters there. I was not part of developing the acoustical section. I went through and researched the CLTs on my own, and lo and behold, we agree. I'm happy. CLTs haven't had a lot of history as far as testing acoustically. So what do acoustical consultants do? We go back to things we know. It's called mass law. We know that if a partition has a certain mass and a certain thickness, it's going to perform the same way. So that's that center section of the graph. So with a CLT, a 6-inch CLT is about the same as 1.6 inches of concrete as far as mass. I know what 1.5 inches of concrete does from an acoustical point of view. So a 6-inch CLT should perform the same way, and it does based on the testing that has been done. Okay. So it's a lightweight mass system on top. It's not the same as concrete, but it's a lightweight system. So again, we're going to have to look at and use supplemental resilient channels, different things, if we're using this as an isolation system between units, between dwelling spaces, between commercial facilities. We can start to see that IIC on their own, they're in the low 20s, which is what we would expect from a very thin piece of concrete. And we can see the STC ratings are in the mid-30s, again, what we'd expect from the same material. So it's going to have to be used in combination with something else. Great material, makes sense, but again, we've got to look at the big picture. Looking at the food chain again, starting on the right, at the low 35s, going up to heavy carpet, up to the high 75, mid 75s. So I really don't have to tell you guys this. When I'm talking to folks in North Carolina, yeah. Talking to folks in San Francisco, yeah. We want things sealed up airtight. Wherever air can flow, so will sound. So we want our electrical boxes, our party and our party walls sealed airtight. We want our doors sealed airtight. We want high quality windows. The insulation we put in our walls needs to be some form of open cell insulation acoustically. Okay? Blue jean material, mineral wool, fiberglass, cellulose blown in, all of those are fine. Where we have problems is when we fill a cavity with closed cell spray and foam. Closed cell foam is great for the air infiltration barrier, but because the cells are closed, sound cannot get inside of it and interact with the material. Okay? So it's a barrier for sound intrusion because we want the sound waves as they vibrate to interact with that loose fill, and that's how we get that reduction. That's how we get that big bang for the buck. Okay. So if we have to, if we're using closed cell for air infiltration, we want to make sure that we have it also a second lift of open cell or come back in and do additional bad insulation for thermal and do a hybrid combination. Okay. Rigid foam, because it's closed cell, doesn't help us at all. Doesn't help us at all. Other things to consider, fiberboard. Back in the 50s, this material was tested in the States, and when you read the test report, they glued the material to the framing system and glued the gypsum board to the fiberboard. If you have a code official that will allow you to do that from a construction point of view, by all means, use fiberboard. Otherwise, my recommendation is run quickly away from it. It doesn't help us acoustically because of the lack of mass. Because I'm going to screw through it into the framing system, so I lose any resilient properties that fiber material had that vibrated back and forth. It's a great carpet underlayment, but it doesn't work acoustically, in my opinion and from the test reports we've done. Adding a resilient channel, coming into having problems. All of a sudden we've got, well, we're not getting adequate sound isolation from one side of the wall to the next. Let's just put on a resilient channel, another layer of gypsum board. Okay? Two challenges there. Anyone tell me what they are?
Trapped air.
Trapped air, okay. Same issue we had with the trapped airspace. Very good. What's the other one? How short of a drywall screw can you have? Most of the drywall screws that they're going to have is what, 1.25 inches? 5/8 gypsum board if we're lucky, 1/2 inch resilient channel. That gives me an extra 1/8 of an inch of that drywall screw that's going to penetrate into the substrate below. So again, it's no longer resilient. They've screwed into the structure. You are much better off if you're going to do this to get the sledgehammer out, hole saw, however you want to deal with it. Bash a bunch of holes, cut a bunch of holes in the existing finish system. Put the channel up so we don't have that trapped airspace. You'll get a substantial improvement, as well as work out all your frustrations for the week. So when we look at this, I mean, this is the test. Same type of material, same investment in materials, same investment in labor. And the top layer is 55 with no gypcrete on top. The bottom layer with the trapped airspace is 38. That is a substantial no-no acoustically. That's a very bad problem. You're going to hear lots and lots of things upstairs. Excuse me. Here's an example off the internet of someone building a studio. How much money have they invested in doing those multiple layers of gypsum board and putting resilient channels and trapping in there? And this is an example of what to do. So be very, very careful when you go out there and look at resilient channels on the internet. Plumbing noise. How do we keep plumbing noise out? Okay, that's a big complaint that a lot of people have. We want to make sure that the plumbing noise is taken care of. Make sure we've got it properly isolated. Condensers. Okay, starting to do multifamily housing, mixed-use spaces when we have condensers on the roof. Okay, got to be careful with that. If they're not adequately isolated from the structure, we're going to have noise. Recessed light fixtures, ductwork for heating and cooling, all of those create holes in our acoustical ceiling. Ideally, we're not going to have those penetrations. We're going to do something with track lighting. If we're going to put recessed light fixtures in, we're going to be dealing with soffits and things along that system. Okay. Ductwork, if we're having duct come in, I want to have approximately 6 feet of internally lined sheet metal duct connected to the diffuser. And then we can go back and do our flexible connection to that ductwork. This was a project in Oriental, North Carolina, the sailing capital of North Carolina. Resilient channels put on parallel to the joist. We always want our resilient systems that are attached to the system perpendicular, so we create a lattice contact, not a parallel contact. And then we had all kinds of other fun things. A couple more photos of that. Resilient channels, we're using them, this is common problems. Resilient channel is put on upside down on the left. That channel is designed to flex out. We want it to pull out so it vibrates. The center photo shows channels put in upside down and backwards. Different directions. The right one shows screws going through the channel into the framing system. Again, channels that are put in backwards. If you look in the center, now if you look in the center to the left of the center channel, you can see screws that are put in through the gypsum board directly into the system. We've short-circuited all of our systems. Attorney got real lucky with this shot. It's not the resilient channel we want, and you can see the screw going through gypsum board, the channel into the system. This is the demise. This is the problem. I don't like resilient channels. I like resilient systems, but I don't like resilient channels. 2 of these screws in a living room will totally defeat all the money and effort that's gone into that process. Sprinkler heads, how do we properly connect those and have an adequate isolation? Ductwork, boxing those. These are all the checklists and the things that we need to look at. And this is the horror story. I'm trying to scare you. I really am. We can do things well, but we've got to have a good crew that's building it. The best design that we come up with is going to be screwed up in the field 19 times out of 20. This project here was done perfectly, and they were still complaining. This was in northern Idaho on the ski hills. It's so quiet there, they were still complaining that they could hear what was going on downstairs, even with the best acoustical detailing. This was that connection of the ductwork being crimped and sound coming in Oriental, North Carolina. So there was really, think about flex duct. There's nothing there, there's no mass, there's no isolation. Sound gets into the joist cavity, travels, breaks into the ductwork, comes out of the diffuser. Insulated contact cans, good, they're sealed airtight. 3 or 4 of those are okay. A ceiling full of them, no. Other framing issues, this is just scary. I've got to go back to San Francisco and do a walk on this job site here, and hopefully they've corrected all these squeaks that we're going to have. Blocking. They didn't take out blocking as they were putting up walls. Soundboard, gypsum board, acoustical board, makes sense. It's like plywood, it's like laminated glass. We're just now getting good acoustical test reports. Damping material, adding glue in the space, again, it's kind of like that laminated gypsum board, helps out. We've been doing this for 40 years with USG. Other stuff is starting to market it. And just be careful when you're looking at the internet. There's a lot of things that aren't right. There's a lot of things, everything, I think the only thing right with this slide is the resilient channels and the gypsum board. Everything else is a waste of money. And then going back to the fiber board, we can't track and make acoustical partitions and follow the fire chain code. Okay, so if a partition is a 1-hour partition and we're doing something built similar to that, we say that it's a 1-hour system. We can kind of make that inference. We can't do that with acoustics, and this is what this one company has done to get their acoustical ratings. They've said because it's UL 503 or whatever it is, assembly, and they follow that through, it becomes the acoustical rating. No, it doesn't. So, while this is tongue-in-cheek, be very, very careful where you get your data. Get it from a reputable firm. You guys are great up here because you've got the Research Council, and I refer and rely on them. So if they've said something is going to do X, Y, Z, it's great. Let's deal with that. So with that, let's open this up for questions. Yes, sir. Do we glue our drywall to the resilient channel? No, we do not. And it's not in the recommended process by what I'll go back to as the authority would be USG, because they developed the product. Yes, sir.
You mentioned the weaknesses of when you screw drywall through into the studs. You short-circuited your resilient channels together, basically. I take it the same happens anything you're attaching to the wall, so upper cabinetry.
So the question is as we're dealing with resilient channels and we're attaching materials to that, if we screw through the channel into the framing system, yes, we're going to short circuit it. As we deal with cabinetry, again, I would urge you to go back to look at the USG handbook way back where, and they show how to add additional resilient channels and how to fasten cabinetry into the channels that are behind the gypsum boards. So there are ways for us to deal with that. And in some cases, it's actually fastening them vertically into a soffit that's been isolated. So there are different methods of dealing with that. But we have to be careful about how that's being done. Good question. Wow, I got off easy today. Well, I'd really like to...
Yeah, so there was one point that you made at the start, which really rang true, where you said it doesn't matter the material, concrete, steel, or wood, you can't achieve the acoustic performance necessary with those materials alone. Yet, in our marketplace here in Canada, the perception is that a concrete building performs way better acoustically than a wood frame structure. So why is that the case? Is the combination of materials easier to achieve in a concrete building than a wood frame building? Why is that perception?
So going back to the question of we can't deal with everything either wood or concrete or metal, but yet here in Canada the perception that concrete buildings perform better acoustically than wood, the perception is from a sound isolation point of view. Concrete by itself is going to be an inherently better, because of its mass and its relative thin in that same footprint of a 2x4 or 2x6. Concrete is going to provide a lot better mass and a lot better isolation, either as a floor ceiling system or a wall system. Now, I can get that same performance out of wood or metal, but for a floor ceiling system, under wood is going to be better because it's going to be better impact isolation. With concrete, we're definitely going to have carpet on top to get that footfall noise. So it becomes back to where that perception is and what the goal is. Or if we're strictly talking about airborne, concrete, yeah, it's going to have a better performance for the same linear square footage or thickness for the ceiling. Wood's going to have a better inherent natural impact isolation than what concrete's going to have. So again, it's part of dealing with that. And neither one of them can do it alone to get to the code. They're going to have carpet, and my joke about kitchens and bathrooms, very true. Or we're going to have some type of resilient system to add to it. Okay? So a plug for Woodworks. I've been dealing with Woodworks North America I'm sorry, you guys are North America, Woodworks USA for the last 10 years. Down below the border, they're a great group of people to work with, just as the folks up here have been a great group to work with. These guys are here as a resource. If you got a code official that's not understanding what you're trying to do from a wood point of view, use them as a resource. They're great help in dealing with the adoption of wood when we start talking about mid-rise and higher-rise buildings. Okay? So with that, if there are no other questions, thank you very much and have a great day.